We have a
howling.
really high frequency noise.
Oh God.
Turn the volume down?
No, try again. Take the speaker. Now they can.
No, we have to call you.
Oh boy.
Okay.
Much better.
Okay, third time. Yeah.
Okay. Thank you for taking time. Today I'm going to give a talk about two parts. One part is yield parts, and the other is CIS parts. And first of all, let me explain for the first pages. So I use this time fertilizer inputs dataset. I made a fertilizer input. So page 1. So this portion. So the fertilizer consumption for maize is a fertilizer consumption multiply A divided by B. And I collected the data sets of the harvested area of maize, wheat, rice, soybean, 4 major crops from the FAO websites. And B is a harvest area of maize. So I calculated the portion of the harvested area of maize, and then fertilizer consumption is the whole China. So I could get the fertilizer consumption for maize in China. So making
and A and B are also for all of China, right?
Yeah, also every maize, wheat, rice, soybean data is also China. And unfortunately, the fertilizer data set is provided until 2002. I don't know the reason why, but from the FAO website, they provide until 2002. Then I made the single regression analysis between yield and fertilizer, and this is the results. So the very good correlation coefficients, almost the same. Very good correlation coefficients. So then, this is the actual value of maize yield, and this is a maize yield fertilizer inputs yield. So, I made detrended lines using the fertilizer inputs curves. So this is the detrended lines of the fertilizer concerned curves, and then.
But you can see the fertilizer effect. You can maybe see. It's going up and down, up. So you can kind of sort of see the coherence.
Yes. So the important thing is maybe in China, the effect of fertilizer input is almost reached to the saturated points, because if they put more fertilizer after year 2000, they don't get more yield. This portion. So just for the comparison, this is a previous survey I conducted last time, and this is the actual value of maize yield, and this is just a trend lines. So this is the detrended lines. So next page 2, the paper printing is not so good, but almost the same. This is linear trend lines, and maize yield actual and maize yield function of the fertilizer inputs, and this is a detrended linear lines, and this is a detrended line concerning fertilizer. So almost the same. So from this figure suggests that the maize yield increase in China is mainly because of the fertilizer inputs. So this is one result. And then I conducted the multiple linear regression analysis concerning fertilizer inputs. So the fertilizer temperature precipitation. Oh, this is an old one. Sorry. Temperature precipitation in September. This is a analysis I conducted before. So this one, sorry. This is results multiple linear regression analysis with fertilizer inputs. The end of page 2. So the regression coefficient for fertilizer and regression coefficient for temperature and precipitation. So if we put the fertilizer as a function, the multiple correlation coefficient becomes very, very good. And then I move to the neural networks. So the Carlos-san provides me the scripts for doing the neural networks, but I'm still
Sorry, maybe before you go so fast.
Yes,
so
yes,
the
yes.
last one.
Yes, yes.
So how come it's so fine? This is
0.9,
0.9.
and the other one was like 0.9. That's a strength.
Yeah, almost zero, almost p-value is very close to zero.
Usually, right? This seems incredibly high. So this is removing the fertilizer input, and then you have the three one temperature and two precipitation in your predictors.
Yes, yes. Other three.
And is that good? And this is we've done the linear training. That's the corresponding.
Yes, yes.
So this is almost no skill. This got huge skill.
So that includes
No.
fertilizer?
Yeah, this is concerning the fertilizer, and this is
Fertilizer
not,
is
a predictor.
predictor.
Yeah,
So that means that fertilizer is the one that is dominating
dominating.
Oh, this one you're doing the.
Yeah,
No.
that one fertilizer is.
This is the trend from the fertilizer.
Yes, detrended yield.
Maybe you should use the trace. The fertilizer remove yield, right?
Yes,
And then you put in temperature and true precipitation, and you got this correlation skill.
yes. And fertilizer temperature and precipitation.
Have you ever plotted this out, see what it looks like? This,
Yeah,
this is huge difference. I mean, it's almost too good.
If we just put the temperature and precipitation as a function, so the multiple correlation coefficient is very low. But if we put the fertilizer as a predictors, the correlation coefficient value becomes very high.
That means that it's almost like the fertilizer is the one that
Yes, controlling the yield.
Oh, you put fertilizer in as a regression coefficient.
Yes,
predictor.
Yeah.
Oh, so that is before you removed it.
Yeah.
Oh, what we were thinking about, you remove the fertilizer and then apply regression.
Conducted, yes.
Yeah, so it would
Yes,
just
yes.
be temperature, precipitation, two precipitation with three predictors. Whereas here you actually have the fertilizer as a predictor.
Yes. In this case.
Oh, that's not very. That's not very interesting. Well, yeah.
Yeah,
Well, it's interesting too.
It's interesting because now we know that that could justify why the fertilizer needs to be removed in order to know the effect of precipitation.
So this is taking out the linear trend. Do you have one where you took out the fertilizer effect and then do the regression?
Yes. Before last week's presentation, from the last week's
Yeah. So
presentation.
this is from last week.
Yes.
But what about take out the? You go back a little bit, scroll back a little bit. A little bit. You know, do the regression on the time series. I was thinking about go back to the time series which was shown.
Go back to time series.
Yeah. Can you do regression on this time series?
Detrend line to
So
fertilizer.
this is the fertilizer remove yield, and then do the temperature and two precipitation.
Yes.
That's
I
what I
should do
think,
that.
yeah.
Yes.
Because the fertilizer is such a strong effect that if you just do it here, it will just come out. Yeah, that's why you got this fantastic correlation.
But it's almost the same. I mean, or the detrended linear and detrended line with fertilizer,
Right.
the value is almost the same.
Right.
So I will check.
You check
Yes,
out.
I check
Yeah,
that.
see
Yeah.
if the temperature two precipitation predictors will improve this one over that one.
But without using fertilizer as a predictor.
Yes.
Yeah,
So
these are already
without
removed fertilizer, yeah.
without using a fertilizer.
Yeah.
Yes, I do that.
So how do you remove fertilizer?
Yeah.
Oh, he just took the difference between this guy and that guy.
Yeah, this one and this one.
Subtract the red dotted curve from the blue curve.
Blue curve. Blue curve is the actual values.
Right.
And red curve is only the yield, only the function of fertilizer.
Okay.
I conduct the first pages. The result is here. And this is very good
Okay.
result.
Yeah, yeah. So based on that correlation,
Yes.
plugging in actual values.
Yes. And this is a linear trend, just a trend. So I will check this portion without using fertilizer.
Because you have, just with the fertilizer, you have 0.91 correlation.
Yes.
So just 0.91 is due to the fertilizer itself. That's why this proportion is so big.
So the maize yield in China is fertilizer plays very important role. I mean, dominant, almost dominant. But what I want to do is trying to figure out the impact of climate conditions. So I do that in several ways. And then I move to the neural networks ways. And this is output of page 3. So the Carlos-san provides me the script, but maybe I have several questions after the meeting. But now I did
the performance. You're not changing the data division of the performance of the training function.
Yeah. This one is detrended line fertilizer is set to be a function of temperature and precipitation, and 42 samples are used. In this case, the result is this one. Not at this time. I have not yet concerning the time division, time difference.
Oh, okay.
Yeah, but just the data sets yield detrended lines concerning the fertilizer is a function of temperature from April to September and precipitation from April to September. So this is the results. So now I wonder
And the linear one was like 39%. So these we're including as predictors everything except the fertilizer.
Yeah.
So when you compare it with the multiple linear regression, what would be like the comparison? So because you have like correlation coefficients of 50%.
Yeah. So maybe I have to add the other correlation.
In order to compare it with the linear.
Yeah.
So
This
one.
one. Yeah, this is the linear correlation. This one. These are the multiple linear regression as concern fertilizer trends. Detrended yield with concerning fertilizer with a function of temperature and precipitation. And the multiple coefficient value is this one, or 0.4.
Oh, so you have that this is
Yeah, so sorry. These different lines.
So you're improving like 0.1, more or less.
So how does that compare with last week? Last week you also did that.
Last week this one is this one, almost zero. Multiple correlation coefficient almost zero.
Oh, so this improved quite a bit.
Improved, yes, improved.
Oh, so taking out the fertilizer compared to taking the linear trend, this was improving too.
Yes.
Oh, so it's not significant.
That makes sense.
Oh,
yeah.
It's good.
Okay, sorry, I did that.
Oh, so even though it's not very high,
it's significant at 5%.
Okay, and this is certainly much better than this.
So using a detrended yield concerning fertilizer input is make progress. Is better. Yeah. And then I moving to neural network analysis. The same predictor
than the one that has like a 39%.
Yeah, this one.
But one thing you have to be careful, like here, if you use the test data, you've got a correlation
Yeah.
You cannot compare with this, because this one is not cross-validated kind of thing. This is just fit the whole.
Or the point.
Yeah.
To get that relation line, you use all the data points.
Whereas if you're actually going to forecast using a multilinear regression, this would fall because you have to do the cross-testing as well.
Cross-testing.
And the linear
Like
ones.
this, right? So you're always applying the regression model to some data it has not seen, so the skill would be less than this. It's sort of like this, like this is less skill than this.
So what's the meaning of this one? I mean, using a neural network's good? I mean,
No. If you want to compare regression with neural network,
yes.
you have to compare it the same way. You cannot compare, say, the correlation skill, the test data here, with the correlations with this, because this is not independent test data. It's just
independent test.
So this one, if you're going to come up with a number to compare with, say, correlation here, you will have to train it and then calculate the correlation with independent test data. So you can do sort of cross-testing as well.
That model corresponds, that value corresponds to the correlation of the whole data set, training, testing, and validation.
Well, just training.
Just training actually.
The skill is just training skill, right?
To the end validate or anything in the linear regression.
So your forecast skill will always be less than this. And that's why people always, they do a regression, they say, oh, I got this good correlation. They use the model to forecast. The skill is always much lower because, there's a difference between training data and testing data. Testing data will always get less skill.
So,
I have a question. The owl there, like the last square in the bottom. So that would be the correlation of the audit data set? Well, this one. So this one should be comparable to this one, is that right?
No, it's still not the same because this one, if you use
just feeding
the whole record to train,
you
will be compared with that because you're using the whole record to train.
But if you're using the whole scene.
Yeah, if you use you just train, then it's compared with this. But you can see skill deteriorates when you use testing data, right? So there's no real testing data there. So you cannot compare.
So in that sense, maybe I have to divide the periods.
Yeah, you have to use the same mechanism. Right? You have to
also not only for the linear, for the neural networks, you also have to do it for the linear models.
So if you're going to test it against linear regression, you don't need validation. Right? Linear regression, you combine these, just train it, and then test it on this.
So the test value is very low in this case.
Oh, I'm sure this is way less when you forecast test is much lower, like maybe 0.2 or something.
Yeah, that's like an advantage.
See, this is 0.146, right?
Probably will be similar.
You see, training is 0.69, and testing much lower. Right? So this may be something similar, 0.4 or something.
そしたら、sorry, I'm still don't confused. I mean, applying for the neural networks is good. I mean, useful.
Well, if there is some nonlinear effect, but it might not be much skill. Like maybe fertilizer controls everything. Well, 90% of everything. So this is very small. So you're still going to get very small skill. So it may not be good. And also you have to cross-validate. So you have to use all the data to come out with this skill. Right? So if you calculate correlation of all the test data done over maybe 4 or 5 periods, and then calculate the correlation.
So okay. So, if we use this neural networks analysis using, the time difference, like this one,
right?
Then maybe we had a possibility.
So you test over all of them.
All of them, yes.
And then you calculate, the forecast value, the true value, and calculate the correlation skill. And you do the same thing with the regression.
You have to do the same with the regression, so you will don't give that linear regression an unfair advantage because now the linear regression is seeing the whole data set to get the correlation. The neural network is just only seeing a subset, a small piece of the information that the linear model is is seen, so the correlations are like not comparable.
So that maybe in that sense, maybe I can explain this portion. For example, the beginning of latest, but around this period.
I don't know. That's
Maybe.
like probably 2 or 3 points. So that drop could be anything that happened in China. Could be like a severe winter.
Yeah, because in China it is said if you put more, we put more fertilizer, the yield is saturated. Yeah, almost saturated now. Because at a long period, if they put more fertilizer, they put more yield. But
So-
the trend is going on.
So this might argue for having the fertilizer as a predictor because neural network treated non-linearly. You know, if it above a certain threshold, the neural network can turn it off, where linear regression cannot do it.
No.
So you should do it both ways. One is to just take out the fertilizer effect, right, and remove the trend, right, and then apply regression neural network without fertilizer as an input. The other one is to actually have the fertilizer in as a predictor. So what do you think, Alex? Does it seem okay? What? The bottom needs to be lit down. So, because if if the saturation effect with the fertilizer used, then he should have fertilizer as a predictor.
Yeah, problem. I just don't give it enough data to be able to tease this stuff out.
Yeah. This is 42 is so ridiculous. Yeah. So our worry is that your record is too short to detect it. But if your predictor, saturates, and the neural network can handle that, it doesn't treat it as a linear variable. It sees that it should saturate beyond.
So they maybe set the fertilizer as a predictors, using fertilizer as a predictors, and not using a detrended lines, but original actual
As a
values.
possible to,
As a okay, I do that.
You see if there's a difference between the linear approach and not.
So maybe we might find the advantage of using neural network
That's right.
for predicting the yield,
Yeah.
and also
If it's
considering the
fertilizer
effects of fertilizer.
Saturation.
Okay. Yeah. And this is so they are now working on the scripts. Carlos-san provides me the scripts for the data. Yeah. And this is a portion of the and this is the predictors. This is another step, another example we have just mentioned. Actual value is used, and as a predictors, fertilizer and temperature and precipitation. This is the result. So the page, not on the, I delivered before.
It's on here.
Yeah, not up here. I did that yesterday. So if as a predictors, fertilizer, temperature and precipitation is used, maybe
There's one problem with your cross-validation approach is that the fertilizer saturation only occurs on the latest few years.
Yes.
So if you're using the earlier year
to
to train it, it will not pick up that effect because it doesn't have, you have not seen the fertilizer saturation.
Saturation, yes.
You won't see it because
No.
if you're training it, it hasn't occurred. So it won't be able to predict it. So he might have to scramble his data or something.
Yeah, it's complicated because it seems that you only have like 3 years of data where it's saturated.
Well, one thing he might be able to do is to divide it into four, right? So you pick year 1, year 5, year 9
Okay.
as the test data. He might have to do that something.
So skip like
Skip. Okay, so maybe the point. So suppose you have year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So validation, you take, testing. So you take this out for testing, that for testing, that for testing. So that's your first test set, right? And train with these guys. And then your next test set is this one, that one, that one. So that forms your second test set, and then the third test set. Because otherwise your predictors, your model would never be able to see the the saturation effect later on.
Mm, 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 mm.
So you might have to.
Okay.
There's a function in MATLAB that does that I was using. It's a divide ran.
Oh, okay.
And it divides it up into the test validation by the training data randomly.
But just, yeah,
No,
just
but
it's
this- but
random.
this is not
This is not
random.
random, but you're selecting the.
Yeah.
Oh,
it'll be
Yeah,
random.
every yeah.
He's using divide rand, that is, that's the default here. You see, this one is divide rand.
Mm.
Yeah.
Okay.
That's the default function.
But this is just kind of random. This
Random,
is
but
random.
in this case,
Yes.
you need to pick exactly the values that you want to use.
Yeah.
Training, testing, and validation.
Yeah, I got the ideas. Yeah, thank you.
Yeah.
Yeah. Maybe.
Yeah. Concern because Theory has like so few points that have like that effect of the
Yeah.
at the end.
Mm.
So,
Yeah, because
the network
most
will
people want to know in China,
Yeah.
because until now they are putting so much fertilizers,
Yeah.
but the yield is not gonna. The yield is almost saturated.
Right.
So they are very wonder what will happen in the future.
Right.
It will be great if you can get information from the last decade.
Okay, so just give you a quick
But yeah,
use a neural network, right?
Yeah.
Because if you put
yes.
a predictor, the regression model, it just
Yeah, just-
straight.
yeah, just
Because this
go
one
straight.
you want it to effectively do this,
Yes.
and your network will model this.
Yes.
Is the amount of area that's being harvested each year constant?
Sorry, I don't know.
The area,
Area, yes.
is it constant?
Area, it depends on the crops.
Okay.
Yeah, some crops they have problems. I mean, if they put if using the same plants
Right.
every year, they have problems.
Okay.
But for example, in rice, they will not suffer from the multiple
No, I
cropping.
mean
and
the amount of area. Is the amount of area, are they planting new area each year, or is it constant?
So it depends. I think it depends. But almost for example, in the northern parts, they are very poor, and in the winter season they have nothing to do because covered with snow and ice. So they only during the summertime they use the same land and put the and they made like maize, for example.
So the area that's being planted and harvested is not changing?
No changing, almost the same. Especially in the Jilin province, it's a single cropping region, so they are very, very poor. And even they cannot go to the cities to earn money, because even in the cities they have no jobs during the winter time. So okay, and the next topic. Sorry, I will do a quick. So now I'm working on the another one, Arctic CIS extent and Arctic flow event in Canada, and I'm now writing the sentences. How we generated the data sets, and then. What I want to do is I conducted the Pearson correlation coefficient first of all, and then Williamson and Dr. Alex provides me a Poisson regression analysis. So what I want to do is using the Poisson regression analysis and the paper at the Lund University. And Dr. Alex provides the papers. And I want to apply for the Poisson regression analysis, but I have still in trouble. How can we apply for the Poisson analysis for the data set? So I made a data set number of Arctic flow event data from December to February, and also the average CIS extent ratio from August to September at position two positions, and also I generated the data sets. For the sorry, not shown here. Here, this one, the time series data sets of this position, this area, C03R05, C03R06, and so I want to apply for the Poisson regression analysis for these data sets. So I'm appreciative if you have any suggestions or.
You go back to your
Yes.
CIS data.
This one.
Here.
Here.
Worry about this curve.
This one.
Yeah. This is very small,
Yes.
So whatever effect this is influencing the atmosphere is probably due to its neighbor himself. This is a neighbor, right?
Yes, the neighbor, next to the neighbor.
So the two are correlated. So I think it's due to this, right? This one there's some real change in ice. This one is almost hardly any good. So
Almost no
I would,
stress.
Drop that one.
yeah, this is probably coming from this guy. It's just neighbor.
This neighbor.
It's physically hard to see this having a big effect. Right? It's just always from 1 something and 0. Because this one is big majority changes. So what about Alex mentioned about this other data set? It's very hard to redo and get all the new data.
Alex provided me a person regression.
But he also sent you this link to another site with a bigger CI site.
The papers related.
Yeah, but there is actually you can actually go and get the data, right?
A web page?
This one. And the global analysis of sea surface temperature. This one, is it? Maybe. The papers.
Is that right?
Is the paper or a web page that? Both.
Yes.
Both.
Yeah. So the data goes back quite a bit longer. But it might be quite a bit of work to it.
Yeah, it will cover the full 1948 onward
Period. Okay.
period in the end-century analysis where you have the Arctic outflow that counts. So you're basically doubling the amount of data you have.
That's good.
You said double.
Double. And the period.
48.
Yes, active event data starts from 1949.
Yeah.
Yeah.
To the recently.
The HAD ISSD data set will go that far back. It goes much further than that, but I wouldn't necessarily trust it. But that's a substantial increase in the amount of data you have.
So you can go all the way back to 49 as well.
49.
But I don't know how much work is to get the ice data and redo it to get the little cell.
Can you get it?
No, I don't think so. Not yet. The longer periods of the CIS extent data sets.
Okay.
Okay. Yes. Thank you.
So you have
One more.